here we go. But for the next one below it, x minus 3 times x plus 3, you can see from the slide, this one, 2 slides open. There we go. Okay. So from here, we have this. We have x times x, it's x squared, x times 3 over here, minus 3 times x, and minus 3 times 3. Now, 3 times x and x times 3 are the same thing. You know, multiplication is, you can multiply in any order you want. So there's cancellation, as you can see here. So we get x squared minus 9. Now, on a quiz or test, you could stop here. I rewrote it as x squared minus 3 squared. That's mostly to illustrate what's going to come next. And for this, it's really the same calculation. We have x times x, right? FOIL, x times x, outer, x times 7, inner, minus 7 times x, last, minus 7 times 7. Let me say that again. I think I went kind of quick. We have x times x times 7, minus 7 times x, minus 7 times 7. And so we get x squared plus 7 times x minus 7 times x minus 7 squared, which is 49. And again, I rewrote it this way. Here, just like up here, these terms cancel. And we have this. And there is something a little bit more general happening here. Okay? There's actually a formula in the background that I'm trying to illustrate. And that formula is on the next slide, which is this. For any number b, this product is equal to this. This is actually what they call a difference of two squares, or difference of squares. That's what this is called. Below it is a generalization of this. Basically, we get the above when a is 1. So we have this also. I mean, here really you don't want a to be 0 because then that's kind of defeats the purpose of the formula. So now we have these two formulas. There's also this one that, you know, again, if you just use FOIL, you get this here. And the middle terms, the way you combine it, right? You add the coefficients. That's all I'm saying over here. So in other words, we get this. Now, am I going to ask you to state these formulas on an exam, quiz, or whatever? No. What's good? The formulas are useful, especially when it comes to factoring, as we'll see. But the formulas are good to know. I mean, if you know you have a product in this form, right away you know what the answer is going to be. Same thing over here. If you have x plus something times x plus something, you're going to end up with this. Something in this form, that is. I mean, there's lots of formulas like this, even in the book. You know, so again, they are helpful when it comes to factoring, especially. We'll see that not today, but we will see that later on. Okay. Before we do another example, are there any questions? Guess not. Okay. Well, here's another one. Yeah, this one I actually did with them. Yeah, let me just fix something. I mean, this is from the other class, so let me just fix that. Biggie. Come on. Takes a while to save sometimes. Up, there we go. All right. So here, again, what we're going to do is we're going to find the product of two polynomials. Find the product of, again, that means you multiply. So find the product of means you multiply. So again, here what I'm going to use is I'm just, again, demonstrating distribution. So let's do that together. So we have x squared. We're going to multiply that by x cubed. That's where this term came from. We have x squared times the second term here. X squared times 5x squared, that's over here. Excuse me, we have 4x times x cubed, as you can see here. 4x times x cubed. Then we have then we have 4x, times 5x squared, right? You see that also? Right, so again, we're multiplying each term from the first polynomial with each term from the second, right? X squared times each term, 4x times each term. And finally, for 3, we have 3 times x cubed over here. Then we get 3 times 5x squared. And now we multiply using what we saw in the first slide. So from here we have x to the 3 plus 2, right? We add the exponents. Like bases, add the exponents. 5 times x to the 2 plus 2 over here. 4 times x to the 1 plus 3. Remember, if the exponent's not written, it's understood to be 1. 4 times 5, x to the 2 plus 1. 3x cubed. 5 times 3 times 5x squared, 15x squared. Down here. I just rewrote it here. And then combining like terms, you get this. As you can see. Okay. So that's what we get. Notice it's already in standard form, right? Because as you read this from left to right, the exponents of the variable get smaller. And that's what should happen. All right, cool. That's distribution. The other method I'm going to show you, I've seen it called the box method. Some people call it the table method or the grid method. It's really the same idea as distribution. It's just a little bit more visual, as we'll see when we do this together. So what I'm going to do is multiply those two polynomials. And I'm going to demonstrate this method. Whatever method you use to multiply polynomials, that's your choice. Okay. So here's what I'm doing. For each term in one of the polynomials, each term is going to give us, I'm going to make a column, as you can see. Right, so x cubed here, we have a column. Minus 5x, we get another column. 1, we get another column. From the first polynomial, the other one that is, each term we get a row. 1 gives us another row. Doing so, we have this table with these empty boxes. Hence the name box method, okay? Or table method, I should say, grid method. But now the question is, okay, what about these empty spaces? We multiply corresponding row and column terms to fill in the blanks here. We multiply them. So in other words, for this one here, we're going to have 7x times x cubed. That gives us this product, which is 7x to the 4. Over here, 7x times minus 5x we get this product minus 35x squared. Oh, okay. Here we have 7x times 1. And of course, that's just 7x. Down here, we have 1 times x cubed. Well, that's just x cubed. You know, 1 times anything is itself. For this one, we have 1 times minus 5x, which is minus 5x, of course. Finally, 1 times 1 is 1. All right, that's good. Well, what do we do now? Well, we have to add up these terms that we just came up with. Well, I shouldn't say that. We add up the terms in these boxes, as you can see. So we have 7x to the 4. We have x cubed, as you can see, minus 35x squared, minus 5x, 7x, 1. And of course, when we combine that, you know, when we add them, we combine like terms. So the minus 5x and 7x gives us 2x. I mean, the way I just listed it, I went this way, 7x to the 4, then x cubed, then I went here to here. Again, really it doesn't matter, but you want your answer to be in standard form, as you can see. So we have that. Notice also, not always, but sometimes we can get like terms on diagonals. For instance, here we have minus 5x and 7x. Those are like terms. These, however, are not, x cubed and negative 35x squared. So, all right. But that's in our first example with the grid method. Also, the polynomial with, press the wrong button. The polynomial with more terms I use for the columns. The one with less terms I use for the rows. That is actually optional. You could use the polynomial with more terms for the rows and the one with less terms for the columns. That's fine. That's fine. I mean, it'll change the number of columns and rows you have, but that's okay.